All right, hello and welcome to the last session in Solar Alberta's 2025 Solar Series, Alberta's first virtual power plant. Today you're going to hear virtual power plants referred to as VPPs quite a lot, so just be prepared for that acronym. We were delighted to have so many people register for this event. Please note that we will be recording this webinar for future distribution. The recording will be emailed out to all those registered and posted on our YouTube channel after it is edited. My name is Heather McKenzie and I'm the Executive Director of Solar Alberta. I'd like to take a minute to acknowledge that I'm hosting you today and working day to day from Amiskwichiwaskahegan, also known as Edmonton, Alberta, Canada, which is located on Treaty 6 territory in the homelands of the Otipemisiwak Métis Nation. Treaty 6 territory is a traditional gathering place and home of many Indigenous peoples, including the Papaches, Nehewak or Cree, Saulteaux, Dene, Blackfoot, and Nakota Sioux, nations whose ancestors have cared for and nurtured these lands since time immemorial. Today, we'll be hearing from Ozair Khan from EPCOR, Stuart Dodson from Zonin, and Kelly Tallis from Solar Utility. Stuart has kindly stepped in for Jeff Farrell as Jeff was pulled away for other business. Following their presentations, there will be a question and answer period in which you can all participate. The entire session is going to wrap up in an hour and a half. Please note that we have enabled closed captioning for this presentation, so you can turn the captioning on in the toolbar at the bottom of your Zoom screen. During the Q&A period, we're going to be using Zoom Q&A for questions rather than the chat box, so please enter your questions in the Q&A section. Also, please click on the little thumbs up symbols to upvote questions that you like. Before we move forward, we're just going to do a quick poll to get a sense of who we have joining us today. Please take a minute to answer the question popping up on your screen now. And while some folks are still doing the poll, I just want to encourage you to take a minute, pop your name, land acknowledgement, any contact info you're comfortable sharing in the chat now and throughout the event so that others can look you up on LinkedIn or email you, and hopefully you can start to forge some new relationships. All right, there we go. We've got 55% solar or solar-related industry professionals here today, which is not a surprise since we pitched this as an industry-oriented session. 21% solar knowledgeable folks in the house. Imagine some of you are micro-generators. We've got some solar curious folks here, welcome, and a lot of government representatives too. So welcome everyone. I see some wires and utility folks here as well. It's great to have you all here. Love knowing a little bit about the audience before we get started. Now a little bit about Solar Alberta for those of you who are new to us. We're actually in our 35th year of operation. We're a nonprofit society that is dedicated to accelerating Alberta's transition to a just and sustainable energy future. We do so by advocating, educating, and serving as an industry and community hub for solar energy. Our membership is made up of approximately 200 individuals and 150 businesses. We also have more than 33,000 followers. We provide a number of services, including managing a solar directory through our website. In this way, we act as a bridge for installers, retailers, suppliers, and other solar-related businesses to connect with their customers and clients. Our directory gets more than 26,000 hits each year, and you can see a link to it in the chat. We also run educational programs such as this Solar Series webinar. As mentioned, today's webinar is our last of 2025, but we're actively planning our 2026 webinar series, so keep an eye on our events calendar, social media channels, and newsletter for more details. You can also find free archived videos of all our previous webinars on our YouTube channel. Just yesterday, we launched the registration for our 2026 Solar Show. We wanted to make sure it was ready for you all today. This is our 4-day virtual solar conference at the end of January, Alberta's biggest virtual solar conference, probably our only one. We'll be featuring seminars for the general public, solar enthusiasts, solar installers, solar developers, and green builders. So definitely check that out. Registration for most of the sessions is free and is available through the link in the chat. In addition to our webinars, we offer a number of affordable online courses for solar industry professionals or those transitioning into the sector. Most of our courses are online on Tuesday and Thursday evenings. Next up is Solar PV Systems Electrical Codes, which starts next Tuesday, November 25th. On-demand recordings of our courses are also available for sale alongside affordable, industry-oriented workshops in the solar training video section of our website. In addition to providing education about solar, we also advocate for it. We are currently rising up for renewables. We have free lawn signs available for pickup in 10 municipalities, and we do offer free delivery in 8 municipalities around Alberta. We also have template letters for you to use on our website asking the Government of Alberta to eliminate the discriminatory rules and regulations that they have established for renewable energy. You can click on the link in the chat to make a free sign order or find our template letters today. Lastly, if you're not already a Solar Alberta member, I just want to encourage you to join. Individual memberships are only $35 and you get access to a variety of benefits, including discounts on courses, workshops, access to member-only newsletter content, website content, and more. If you're looking to support the work that we're doing in additional ways, please consider volunteering or donating. All right, I want to take this opportunity to thank Lakeland College for sponsoring today's webinar. We really couldn't offer all of this amazing free content without the support of our sponsors. I'd also like to thank EPCOR for being the workshop patron and making this event free for everyone to attend. We typically have to charge a little fee for industry-oriented events like this one, and didn't have to today because of EPCOR's support, so thank you. We are always interested in developing more partnerships for our events, and we still have one solar show left for sponsorship. So if your organization wants to work with us to educate the public about solar and solar-related technologies, please don't hesitate to reach out. Now, without further ado, I'd like to introduce our 3 speakers for the day. First up will be Ozer Khan. He is the Senior Engineer of Grid Transformation at EPCOR Distribution and Transmission, Inc. In this role, he works to support increasing electrification by conducting research and implementing projects and initiatives for EPCOR's electrical distribution system in Edmonton. Ozer has a master's degree in electrical engineering related to energy systems with a focus on data-driven planning techniques. So welcome, Ozer. The next speaker after Ozer will be Stuart Dodson, and Stuart is the Senior Regional Sales Manager for Zonin, leading virtual power plant channel and project sales across Canada and the Eastern United States. Since joining Zonin in 2023, he has driven new market development and built strategic partnerships with developers, EPCs, installers, distributors, cooperatives, and utilities. Stuart represents Zonin at industry conferences and roundtables, contributing expertise on VPP design, distributed energy resources, and emerging grid flexibility solutions. With more than 16 years of enterprise sales and business development experience, Stuart specializes in introducing innovative technologies to evolving markets and simplifying complex energy concepts for diverse audiences. He holds an MBA in strategic marketing from Clemson University. We're pleased to have you here today too, Stuart. And next up is Kelly Tallis. Kelly is the co-founder and CEO of Solartility Energy, Inc., an Alberta-based electricity retailer driving the adoption of virtual power plants and renewable energy aggregation in the province. With extensive experience in market development and energy innovation, Kelly pioneered the use of bi-directional interval metering for small microgenerators in Alberta, laying the essential groundwork for effective VPP deployment and time-of-use rate enablement. Passionate about addressing the climate crisis and reducing greenhouse gas emissions, Kelly has positioned Solartility at the forefront of Alberta's sustainable energy transition. Kelly remains committed to advancing decentralized energy solutions to reduce electricity costs, enhance grid resilience, and significantly lower carbon emissions. And so welcome all 3 of you. I'm going to turn the screen and mic over to Ozer now, and I'm really looking forward to chatting with you all in the Q&A.
Awesome. Well, thanks so much, Heather. Good morning, everyone. Thank you for joining us today to learn about Alberta's first virtual power plant. We have a very informative presentation coming up. I will start us off just by discussing some high-level details about the project before passing it on to my colleagues, Stuart and Kelly, who will dive into the details on the virtual power plant platform itself and also the sort of the customer financial model that's going to make all of this viable in the long term. Let's see here. Okay, so here's a broad overview of what I will be covering over the next 10 to 15 minutes. we will start by establishing who EPCOR is. Given the somewhat unique nature of the Alberta energy market, it's important to establish the players and roles for each entity, just because there are some guardrails between regulated and unregulated sides of the market. And then we'll discuss what a virtual power plant or VPP actually is and why they're important. Then we'll get into some of the details about the landmark VPP project specifically, and discuss the benefits of the project and how we've been pushing the envelope on advancing this technology in Alberta. And finally, I'll discuss the progress we've made on the project so far, so everyone can get an idea of where we are and where we're planning to go next. And so EPCOR is a municipal utility. We're owned wholly by the City of Edmonton, and we operate power, water, and wastewater services in the City of Edmonton, and a mix of these services in BC, Alberta, Saskatchewan, and Ontario, as well as some of the southern United States in Arizona, New Mexico, and Texas. Most of our power operations are in Edmonton, with a small operation in Collingwood, Ontario, and the rest of our services outside of Edmonton tend towards water and wastewater services. So that's kind of a general sort of who is EPCOR, like the corporate entity. Now, I am here today representing EPCOR Distribution Transmission Inc., as Heather mentioned, which is the owner and operator of all of the transmission and distribution wires in Edmonton. So we don't have any generation facilities, and EDTI does not buy or sell energy in the Alberta wholesale energy market, nor do we sell energy to customers as an energy retailer. And those are the guardrails that I was talking about. We're fully regulated by the Alberta Utilities Commission. So the way that we do work is not directly customer focused, right? Like the energy retailers actually are responsible for dealing with the customers, enrolling them in the retail programs, and the generators are also part of the deregulated market, and they generate the electricity and bid in to the system, along with all of the solar generators as well. So EDTI is primarily in Edmonton, and we operate a small utility in Collingwood, Ontario as well for power services. Just to get some idea of the EDTI's demographics, we have around 450,000 customers. We're 99% urban demographic, except for sort of the annex portion of Edmonton in the southwest. We operate transmission voltages from 72 kV all the way up to 500 kV. We have 35 transmission substations that feed 304 distribution circuits. And the distribution voltage levels that we operate are 5 kV, which is slowly being phased out, and then 15 kV in the core city, sort of inside of the ring road, Anthony Henday, and 25 kV sort of more outside of the Anthony Henday ring road. So that gives you an idea of who we are as an organization, and sort of what our sort of interest in virtual power plants actually is. We're interested in managing the load, the demand, and the generation on the wires themselves within the city of Edmonton. So with that sort of established, let's talk about what a VPP actually is. So the definition we sort of agreed on as an organization is that VPPs are networks of small energy producing or storage devices like solar panels and batteries that are pooled together to serve the electricity grid. With their participants' approval, their energy can be tapped by utilities during times of high demand or can be reserved for later use. And the opportunity that VPPs give us is that they use software to aggregate and control the DERs of all the members, creating a flexible and reliable supply of electricity that can respond to demand and market signals. VPPs can benefit customers, grid operators, and the environment by reducing peak load, providing ancillary services, and increasing the use of renewable energy resources. That's like a very broad definition, right? If you look at the infographic on the screen here, you can sort of see that there's a number of resources that could be a part of a VPP, including electric vehicle charging, renewable generation like solar or wind, battery energy storage, and smart appliances. You might have heard in other jurisdictions, I believe in Ontario, they have a thermostat program, right? So even that could be classified as a virtual power plant because they are able to modify their demand by acting as a flexible load by modifying their temperature settings in the homes. And then with all these other assets, you basically increase the robustness of that demand response profile. Now, the key factor that I want to sort of highlight is this two-way flow. In a traditional grid, you have unidirectional flow of power and information. Power flows from the generator to the customer through the transmission and distribution system, and then information typically flows from the customer to the utility or the system operator, right? In the form of like the amount of demand that's on the system. But as we move into a world where we have more and more renewable generation on the consumer side, we have energy storage, and consumers' needs are changing based on their use of electricity and the types of electrical appliances and like transportation that they may or may not have, electric heating and cooling, things like that. We have to look at how we can be more intelligent about how we operate the grid and how we look at all of these resources. So the grid of the future, or what in the literature is called sort of smart grid, is characterized by this two-way flow of power from the generator to the customer and from the customer back onto the grid. And then also a two-way flow of information, which you can see in the green arrows at the top of the infographic there, where information about status and demand monitoring is passed to the utility control center, and then the utility control center is able to enact certain amounts of local site control and dispatch. So this is our path to smart grid, right? Like getting from unidirectional grid to a bidirectional grid, and this is there are a few goals to sort of get us there. In the case of this VPP project, we wanted to technically demonstrate the integration of a VPP solution that has utility monitoring and grid support functions in conjunction with dispatch control. We wanted to develop an operational model that meets Alberta's regulatory environment, and we wanted to develop sort of the economic benefits of a VPP system in Alberta within the Alberta context again, and establish a business model for widespread adoption. So I talked a little bit about utility integration, but let's talk a little bit about the benefits of VPPs even absent of fully integrating with utilities. So they still have a lot of benefits. They allow greater impact and market participation for customers. Customers are able to directly, by pooling their resources together, they're actively able to participate in the market, whereas an individual customer wouldn't necessarily be large enough to actually move the needle at all within the market itself. But by pooling resources together of 100 customers, 1,000 customers, they can actually move the needle substantially. So that's a really key sort of aspect of just being a part of any sort of virtual power plant program. They can improve grid resiliency just by virtue of, especially if you have energy storage, by virtue of being able to manage the demand at the point of demand. You're able to de-bottleneck everything upstream of that. So by co-locating generation and energy storage at the point where they're going to be used, you minimize losses of those of that generation by transmitting it through the system, and you also can reduce the impact on the grid itself by actually handling the demand where the demand is. Again, balancing supply and demand. A big sort of challenge with solar is that it produces when the sun is out, and all solar is producing when the sun is out, right? So that's not necessarily when the grid needs it, though, right? That's kind of the challenge. And so by being able to store that energy and utilize it later, you're able to balance that supply and demand so that you can actually have supply when you have the demand. It improves the coordination of batteries. By, again, pooling those resources together, you're able to make larger impacts on the system and in the market itself. Improves the use of solar PV, right, by shifting when the solar is actually utilized from when it's not necessarily that useful to when it is useful. And we've seen that there's been great success in other jurisdictions, which I believe Stuart is going to talk about in his presentation. But if we integrate with the utility, the benefits are actually magnified substantially. So I talked about enhanced grid stability and resilience. Well, VPPs can be used to actively resolve capacity concerns on the grid if they're actively integrated with the utility. The utility has really good grid awareness, right? Especially if the utility is using an ADMS or an advanced distribution management system, and are also using like a DERMS, a DER management system. And those are basically software platforms that allow the utility to have like real-time view of what's going on the grid and take advantage of the power flow softwares and everything to operate the grid in a real-time way with really high monitoring capability. But if you are able to integrate the virtual power plant into that same control system, you can now actively use that grid awareness of that knowledge of where there are issues on the grid to then dispatch very precisely the resources that are going to be able to help resolve those issues. So that's a huge deal, and that's something that we're doing in this project that is unique. And I believe it's the first in Canada that's going to be fully utility integrated, which I'll talk about a little bit more later in my presentation. We can talk about cost savings. So we can reduce or defer some infrastructure investment due to the ability to actively dispatch these virtual power plants in that very surgical way. And now the way that this works is, as I mentioned, by co-locating the generation with the demand, whether it's battery or solar or whatever, we're able to actually decrease the demand seen on the system from the wires perspective. And by debottlenecking the entire system that way, you're actually able to increase the overall performance of the system and decrease the amount of asset wear, which can then defer or reduce the need for additional infrastructure investment, which brings those fixed fees on your bill, either keeps them the same or potentially brings them down, which is of net benefit to everybody who uses the grid. Greater participation, customer participation in the energy market. I talked about the customer side potentially, and Kelly will get into a lot more detail about this, but they could potentially make money through their retail program. However, by deferring the asset replacement or asset upgrades that would otherwise be required by not having VPP, we could see a world where we can develop the regulatory framework for actually having the utility pay for some of these services, right? The utility would then pay for the ability to use these assets, and the customer could have an additional sort of stream of income from participating in the virtual power plant, both from the utility side and then also from the energy market side. So potentially some increased customer participation there as well. And then greater impact on emissions reductions. Again, by pooling all of those resources together in a very intelligent and surgical way, and then dispatching them in a very effective way to reduce peak, you can potentially decrease the reliance on costly and less efficient peaker power plants, that have to kick on when demand goes really, really high in those periods between 6 p.m. and 10 p.m., especially in the wintertime. That we've seen some emergency alerts related to that in the last couple of years. So those are all really good reasons to integrate with the utility. Now, let's talk a little bit about the actual landmark virtual power plant project. So in 2023, Emissions Reduction Alberta started a grant program called Reshaping Energy Systems, where they sought out demonstration projects with a focus on technologies that will reduce emissions and contribute to a more flexible and sustainable energy grid in Alberta. Landmark group of companies gathered together a team to demonstrate a VPP project, which would connect a group of highly energy efficient solar plus energy storage homes to create a dispatchable virtual power plant that will improve the resiliency of the electrical grid and enable more widespread adoption of net zero homes and virtual power plant technology. The proposed project includes 100 net zero and highly energy efficient solar homes that are connected to the Zonin VPP platform. By integrating the VPP platform with EDTI's Distributed Energy Resource Management System, or DERMS, and SolarTility's billing and energy optimization systems, the VPP brings industry-leading visibility and control to behind-the-meter energy storage resources and enables the grid operator to fully access the DER resources in a highly energy efficient residential dwellings to address demand impacts on the grid. So that's a high-level summary of what the project was, how it sort of came about. Here is the project partners. So of course, this kind of novel project would not be possible without excellent partners. And I've listed the main sort of partners on the slide here. So I'll briefly go over all of them. Starting with Landmark Homes. They're the builder of the homes, and they're ensuring that all of the required installations and permits are in place for each of the VPP homes, so we can get the solar, we can get the batteries installed, we can submit the microgen application so that they can be registered as official microgenerators in Alberta. We have EPCOR, of course. EDTI is the wires owner and operator. We're providing the integration to the EDTI ADMS and DERMS systems, and we will be doing the dispatch of the VPP for grid support functions, as well as providing the bidirectional interval meters and billing information to the energy retailer so that customers can be compensated appropriately for their generation and participation in the project. Zonin is providing the batteries and the VPP platform, which aggregates and directly dispatches the VPP assets. So Stuart will discuss more details about the batteries and some of their projects in his presentation. SolarTility is the energy retailer for this VPP project. They have a novel and innovative retail plan, which will let customers take advantage of the solar plus battery combination, and which Kelly will talk more about in his portion of the presentation. And then we have Shell. Shell is providing a lot of the back-end project management and logistics support, including facilitating the delivery of the batteries and ensuring that we have everything that we need to be productive. Shell is expanding their like non-fossil fuel based projects and acquisitions quite a lot, and so they're a big supporter of this project. We have the Blatchford community, where the first portion of these VPP homes are being built by Landmark Homes, and so they've been a big supporter by allowing us to go in and by building these homes that are actually not connected to the Blatchford district energy system. It's a different way of connecting in Blatchford, but potentially very nice and lucrative. And then finally, we have the University of Alberta, who is going to be doing research using the data from this project to support development of VPP design and dispatch optimization methods. So as you can see, we have very strong world-class partners with a proven track record of delivery, from the community to the builder to the technology and retailer, and to the utility and academia as well. And all partners have a direct connection to Alberta, which is going to increase the benefit to Albertans. With this project, we're hoping to show benefit to all of the major stakeholders. So this is a sort of a high-level diagram of how this whole thing is going to work. All of the VPP customers are going to be able to connect to the grid, and together, you have a nice little graphic of the ants lifting a boulder together. We're going to be able to fill in that off-peak load in that graph there, and then use that capacity that we've built to then shave the peak of the system, and thereby try to flatten sort of the load profile of the distribution feeder, which will benefit the distribution feeder by increasing its asset life capability and decreasing the requirement for costly upgrades. Now, all of the major stakeholders will benefit from this project. Landmark Homes is a builder of net zero homes in Edmonton, so they're going to continue to push the envelope on their net zero home design. The customers are going to get access to subsidized PV and energy storage equipment, as well as access to the virtual power plant and aggregation of all of the resources for optimized usage. The energy retailer, in this case Solar Utility, is going to be able to design and offer a competitive rate plan, which takes advantage of the VPP aggregation of resources for energy arbitrage, as well as for auxiliary services, which can be sold to the distribution facility owner, the transmission facility owner, or even the system operator. And the utility, which is EDTI in this case, is going to be able to intelligently utilize a large dispatchable asset to lower peak loading and optimize use of the existing infrastructure and minimize need for those costly upgrades. And here I have a diagram sort of showing the unique aspect of this project. So on the left-hand side there, you see those houses. The houses have different levels of sort of the behind the meter resources. You can have solar plus battery, EV, or even just battery, right? And all of those assets are then connected to the internet via the customer's Wi-Fi, and they're able to connect into the cloud and talk to this grid edge DERMS, which is providing all of the VPP functionality, right? So we classify the Zonin system as a grid edge DERMS because it is directly interfacing with the edge of the grid, and it's doing DER management. And so the VPP platform does behind-the-meter DER monitoring, and it also does behind-the-meter DER dispatch, and it also takes care of the customer enrollment piece. And then over the internet again, we're able to communicate with a grid DERMS, or the utility DERMS, or the enterprise DERMS. You might hear many different sort of like terminology around it. But essentially what that system is doing is it has full grid awareness, like it has grid monitoring, it has grid control, and it now has behind-the-meter resource monitoring because that information is being piped over from the grid edge DERMS, right? And the grid edge DERMS can be a third party, or it could be a utility-hosted grid edge DERMS. But in the case of this project, it is Zonin that's hosting that, and they're piping all of that information to the EDTI systems. And we're importing all of that into our ADMS model, and then directly using it in our system calculations so that we always have a good awareness of what the VPP is doing, as well as what the rest of the grid is doing. So with that, let's talk about the actual project and where we are as of today. So as of this morning, we have 8 houses currently with batteries installed, and all 8 houses are currently loaded into EDTI's ADMS system, which I'll talk about in the next slide. And there are 18 houses planned to have batteries installed by the end of the year. So that'll bring us up to 26 houses for this year that have batteries installed, and we're planning to do, I believe, 25 houses, at least 25 houses for the next 3 years after, to get to that 100 homes target. And this is, there have been a lot of challenges to get to this stage in the project. Everything from fire codes to the actual permitting for the batteries, figuring out how batteries need to be installed, like how much space they need around them in the houses, sort of mechanical room, and also being able to expand outside of Blatchford to target like other new neighborhoods, so that we can expand the capability of the virtual power plant. Those have all been major challenges that have been addressed and continue to be addressed as we move the project forward. But so far, we're able to, the 8 houses that have batteries, we have full information on all of the battery assets and the solar and their generation being piped into the zoning system, and then from the zoning system into our ADMS system. So the next thing that I want to talk about is the actual ADMS modeling. This is what I directly work on, so I'm very passionate about this part of the project, and we're using this project as a test bed to showcase a number of advanced functions within the ADMS to prepare EDTI for greater DER and smart grid technology adoption in the future. So with this project, we had 4 specific goals that we wanted to hit. We wanted to interconnect with the VPP aggregator and operator from the ADMS. We want to integrate the VPP customer data directly into the ADMS customer models. We want to do real-time monitoring of the VPP status through the DERMS functions, and we want to do real-time control of the VPP via setpoint command for grid support. And as of today, we have achieved all 4 of those targets with the 8 houses that are currently available for dispatch. So that's a huge milestone for us. Took a lot of work in terms of the modeling requirements. If you'll allow me to nerd out just a little bit for a couple of minutes, one of the biggest unique aspects of this project is that we're doing a direct integration of the VPP platform into the utility control system, the utility ADMS, and that's very new. And it's other jurisdictions that have virtual power plants typically have the 2 screens, right? The operators see 2 screens. They see on one screen they have their control system, which is grid aware, as I mentioned, and it knows, it has all of their switching steps, it has all of their assets in it, right? And then on another screen, they've signed into a web portal to access the VPP platform. And they look at their ADMS screen and they see, okay, I have an issue in this portion of the system. And then they move over to their VPP platform screen, and then they enter whatever information they need in there to dispatch a command. And then they sort of go back to this and they see whatever they see, right? But that is kind of clunky, right? In the initial iteration, that was the only way to do it. But I think now with the functions that are available in modern day control systems, modern day ADMS and DERM systems, as well as the VP platforms themselves, and the ability to actually set up connections between them, we're pushing the envelope on that. We're taking it to the next step, and we're the first in Canada to actually do this full integration between the utility ADMS DERMS and the grid edge DERMS of the VPP provider. And what this does is it allows all of the information that's coming in from the VPP provider to actually contribute to the system model that the operators are seeing. So the ADMS runs a power flow calculation, and it constantly runs this in real time, and that's what actually tells us how much load is on every single wire in the system. Now, because we are able to import all of these customer battery assets and solar assets into that power flow model, the power flow model takes those into account. So if we know that there's generation being output on the system, then we know that the cable the load has gone down on the cable. And we know that if a lot of customers are charging their batteries, for example, from the grid, then we know that the load has gone up. And we can see that in real time on the system itself, which gives us a lot more options for using forecasting techniques and using look-ahead techniques to actually figure out where the problems are going to appear, and then plan for those dispatches ahead of time so that we can dispatch at the appropriate time with the appropriate amount right through the control system. And so the operators only have to deal with the software that they're most used to dealing with in the format that they're most used to dealing with it. And so the screenshots that I'm showing here actually show the ADMS view that our operators currently see. So on the left side there, you can see that there are some houses and they have some values next to them. Those are the values that are being pulled in from the zoning system. And then on the right side, you can see the cluster, zoning cluster 1. That cluster includes all of the landmark show homes that currently have batteries installed. We didn't want to, during our testing especially, we didn't want to cause any sort of financial stress on actual customers. So Landmark graciously volunteered to take the hit for any dispatch commands that we were sending while testing. But you can see here that we're able to monitor at the cluster level and at the individual customer level directly in our control system, and then dispatch directly from the control system. And we also have some calculations running in the background to generate the amount of dispatch required to address any given sort of overload issue. And then the bottom screenshot there is within the Zonin platform itself. You can see that when we issued the command, the batteries did actually respond for this specific customer, which is one of the show homes. And you can see that we issued a charge command, so the battery charged up, and then we released our control, and the battery coasted for a bit. And then once the load went up, the battery started discharging to meet that load. So very exciting. We've hit the main sort of 4 targets that we had, and now it's just a matter of scaling it up and making it easier to enroll into it, and then automating a lot of the intake so that we can scale it up to the 100 houses and then potentially beyond that as well. And then I talked a little bit about the bidirectional interval metering. So we've recently completed an upgrade to our billing system to accommodate residential bidirectional interval metering, which is different. Typically, your residential meter is a cumulative meter, so it aggregates the customer loaded generation to the hourly level. But to participate in the wholesale energy market, for example, you actually need 15-minute interval data. And so we've recently started programming our meters to do interval metering as a part of this project. And so we've prepared 100 residential interval meters for this project that are programmed to provide the billing and settlement files at that 15-minute interval rate resolution. And we're able to provide those files directly to the retailers. Any retailer who's able to ingest those files is able to then set up their billing and settlement to accommodate that. So now that ensures that customers can be adequately compensated for their participation in the program. And we're not doing questions right now. So I will now pass the mic over to Stuart to talk about the VPP platform. And then Kelly will talk about the financial model afterwards. Thanks so much.
So hello, everybody. My name is Stuart Dodson. As we said, I'm going to go through and kind of look at the virtual power plant, not necessarily similarly like Ozir did, but really for the focus of who is Sonnen, what's going on, why is it needed, and then kind of finish it up and transition over to Kelly with what Solartility is doing very different and unique for Alberta. But going back to who is Sonnen, we are more than just a battery company. We feel that we're a global leader pushing a lot of things. We've been doing this for about 15 years as net metering. And I believe Alberta is sitting at the beginning of a duck curve. If you look up what the solar duck curve is, it's starting to push that standalone solar needs more. And that's where battery comes in. That's where energy storage comes in. And Sonnen has been built and designed since day one back in 2010 to do much more than backup power, do much more than net metering, really try to drive long-term value for the grid, for grid optimization. So that's kind of the mission per se of what we're doing there. We are a German-based company. That's where our heritage is. Back in 2010, founded by some very forward-thinking, innovative leaders. We've been a leader in terms of battery chemistry. You'll hear batteries called lithium iron phosphate, LFP. We've done that since day one. It's the safest battery chemistry out there. If you think of a battery catching fire, that's a cell phone lithium ion battery or aspect. But lithium iron phosphate, LFP, that battery is one of the safest battery chemistries in the world, robust, heavy, but can just do a lot. And that's been our focus. We have been recognized as a leader. We're a virtual power plant leader in that aspect. We run probably the world's largest in Germany. We brought it here to America, and we are also owned by Shell. And so been that since 2019. I'm based in the U.S., and so our headquarters for the Americas is based in Georgia. And so that's where we are from that aspect. In terms of product, what does Sonnen deliver? We are a battery hardware company designed for grid optimization and virtual power plant, and we're a software virtual power plant management platform and designed from that aspect. And so we believe in strong, efficient energy and battery management, and then offering a full suite of services to utilities. And what you'll see that we're able to do here in Alberta, and what Solar Utility brings that I feel, is we're hitting it from both sides, coming from the standpoint of the utility, but you'll learn even more of why this is a benefit for the homeowners, the businesses, those types of things. And that's it's a really unique play that we're seeing happen in Alberta. Very happy to work with EPCOR and Solar Utility and the other partners with this project. Staying in a mindset, kind of like is what Ozir was talking about, is kind of the why. Why is this needed? We see it from the evolving energy system that we've got. You're getting large erratic loads that are happening. That started way back in with air conditioners, anything at that level. Now it's moved forward in terms of modern homes, EVs, these types of things, and pushing it. And then as well, we've got the strong desire to look at moving away from coal and or areas, or reducing, or finding more sustainable, cleaner alternatives. And that's where solar and wind come. So they've been able to drive a lot of generation in this intermittent way. And what we feel is a battery starts to bring that into play and bring some more consistency on that. Staying in the aspect of kind of why it's going on, is we like to think of a virtual power plant, because we're a battery company, we call it a distributed battery grid management system, a dispersed area. And so what we felt like needed to happen is those batteries, those assets need to be directly tied to the utility's grid operating system, as Ozir was talking about, we're able to. They want to be automatically and interactively dispatched, and make sure that batteries can be accessible assets daily, sometimes multiple times a day. We're successful in virtual power plants in multiple continents. In North America, the U.S. has five total, with EPCOR. We'll launch another one in Georgia very soon in the U.S. So, and then with it, the WattSmart, which is a program we have in Utah, is probably the most sophisticated advanced virtual power plant in the Americas. And they call on batteries really 1.5 times a day. They've been able to shut down coal peaker plants, and they've been able to incorporate just the batteries, which probably 80% of those batteries are residential. Those batteries are actually a part of their integrated resource planning, meaning they can guarantee they're going to have that type of generation to help them balance out the grid. And that really is our broad objective in terms of the grid optimization aspect of kind of helping balance and harmonize the grid, prevent congestion even before maybe it's needed, by working at that end user, what we call behind the meter level. Jump to the next slide. Really kind of in that advanced battery VPP, it's a pretty easy step process to get to it. First, you need to have behind the meter, that's the BTM energy storage resources. They get interconnected via software and a platform. As Ozir was talking, you can form locational clusters. Those clusters are able then to respond and based on specific load pockets or areas. Why that's a benefit to users, battery owners, homeowners, commercial, they can help a utility reduce their CapEx costs. They may not need to upgrade or build a new substation. They can start using these assets there. And then as these clusters are being used and such for the various grid services, as Ozir already mentioned, that's when a utility starts to see the other value. And there's aspects to where an asset, a battery, isn't just a backup device for you. And as Solar Utility will show you, not just a device that can help you start managing cost effectively more your own energy usage. It's also going to be an asset that the utility taps into, and that asset may even be able to drive profits back to the battery owner, because it's a value driven aspect of what they're able to provide in terms of a grid service back to the utility, even more than just a holistic or a community service in terms of just more sustainable, greener opportunities. Kind of the why, what we feel, and this why is really more on what batteries need to be able to do to assist with this kind of future or better VPP, is one, they need to be tied to solar. Solar alone isn't necessarily the answer. You're at the beginning of a duck curve, and you'll see, so you can jump ahead and be forward thinking, adding a battery. And then what that's going to do is it's going to give you both the community, the grid, and homeowners and commercial owners you're going to get energy system flexibility. Really, you're going to be able to smooth loads out. You're going to be able to manage your own energy needs. You're going to kind of prevent congestion earlier for the grid. It's going to benefit you and the community as a whole. As we mentioned, batteries need to be directly integrated with grid operators, be accessed in real time, be able to be daily dispatched, have a smart, deep, robust electrochemical battery makeup so they can be used and last for a long time. No one wants to buy a battery today and think you're going to replace it in 5, 6, 7 years. You want a battery to last 10, 12, 14, 15 or more with that. And then you're really looking at you're going to be proactive. This is going to be looking for communities and organizations looking to be proactive to create that more stable, nimble grid of what we're doing. Only a couple of slides left for me, and I look forward for everything we're doing, and it's a pleasure. But what we look at is that VPP energy system of the future. We'll go the Gestaltish way. The whole is greater than the sum of its parts. And these VPPs need to be, just as these bullet points say, decentralized, digitized. They need to be bidirectional. That way it's not just an asset that only the end user uses. It needs to be tapped back into the grid to assist. And that really goes to the last bullet point in terms of being resilient. It's going to create a much more resilient community, a much more sustainable energy system of the future. And that's going to be cleaner for everyone. My last slide before passing it to Kelly is really to look at the point, because I didn't want to dive into necessarily battery per se. It's more understanding, but the Sonnen VPP and the Sonnen company, we provide a lot of grid services. We do 11 in Europe, 9 in Utah, happily working with EPCOR as they evaluate things and what they can do, and we can continue to expand. We've got over 15 years of experience. We're this is 11th generation of product that we're launching there. So that means we've been doing this for a long time. But most importantly, is that last bullet point. We like to be an authentic market participant. And what that really means is we want to partner with the utilities, partner with groups like Solar Utility, partner with Solar Alberta, and these types of things, because it's really going to increase and benefit everyone, all battery manufacturers, battery vendors, as we work to be better and to offer more than just simply backup system for when the grid goes down. That's the short version of what we've got. Let me go ahead and pass this off to Kelly, and you can learn about the power and excellence that Solar Utility provides.
Thanks, Stuart. Thanks, everyone. Excited to be here with EPCOR and Sonnen to share our experience with the Blatchford VPP. And thank you also very much to the team at Solar Alberta for hosting. Alberta's energy future is being built collaboratively. And I'm proud that Solar Utility gets to be one of the puzzle pieces in the mix. The climate challenge is huge, but so is the potential for VPPs in Alberta. There's still hope. We've got the space, the sunshine, innovation, and evolving regulation to support it. And Albertans' attitudes of let's just get it done. It's a great recipe to build a virtual power plant. Briefly, who we are. Solar Utilities Alberta's homegrown DER aggregator. We're also a licensed electricity retailer. We were founded in 2020. We've built Alberta's first market rate plan for small microgenerators. We'll talk about that in a bit. And we, as a retailer, we operate the Blatchford VPP as retailer and aggregator. Important, our mission here is to aggregate with the entire community of solar installers and market participants, other retailers, and distribution companies, a gigawatt of distributed energy resources by 2035. We think that that's practical and achievable. And it's basically creating a massive virtual carbon-free power plant. But instead of a centralized power plant, it's in people's garages and basements instead of a field. So Blatchford VPP is a fantastic start. We're actually organized into a group of companies. We're an independent power producer. a licensed electricity retailer, and a virtual power plant platform provider. We built a grid edge DERMS right here in Calgary called Derby. We've talked about the challenges, but the grid in Alberta really is under tremendous pressure. And if we just look at one aspect, the data center applications, I'm sure everybody's seen the AESO numbers. Alberta is about to go through a massive low growth super cycle, maybe unprecedented. There's 16 gigawatts of applications. Only 1.2 gigawatt is approved right away, but really it's an enormous opportunity in Alberta, for the solar industry, for the renewable energy industry. We need more power, and we need more support for the grid in order to get even part of the way to this massive growth. Infrastructure expansion can't keep up. We have to tap the demand side, as so many other markets, electricity markets have. So really what it presents a fantastic and enormous opportunity for every smart home to become a flexible and dispatchable grid asset. So Blatchford VPP is a fantastic foundation and reference for how we can build that together in Alberta. To meet part of this demand. Virtual power plants are not the whole solution. It's a part of the solution. Now, breaking it down, a VPP to add some color and flavor to what we've discussed, and still, instead of building one giant plant, we're just orchestrating thousands of small flexible assets. You could think of it like an orchestra. On the left side is the orchestra. Solar is the strings, batteries are the brass, EVs are the percussion, and aggregators like us and other retailers, including Sonnen, perhaps we're the conductors in that orchestra. What's really important here is to note that there's multiple distributed energy resource types. We're focused on PV, electric vehicles, and ESS, but it also includes thermostats, heat pumps, any other smart home device that could, in the future, participate in a demand response program. On the right side, grid services. I'll talk briefly about that. We don't have a ton of time today, so I'll kind of take a fast-paced approach. But in the future, with the with the REM happening and the changes to the market, the restructured energy market, we see the potential to be able to aggregate distributed energy resources and participate in the operating reserves, and also directly in DFO programs that are already really in the works. With AESO and operating reserves, it's the potential for DERs in aggregate is to participate in fast frequency response, the ramping program, R30, and emergency demand response. There should be a pilot next year with AESO, which will allow aggregation of residential DERs. With DFOs, distributors, we see interest and potential for voltage regulation, demand response programs, and separately with aggregators like us, price arbitrage opportunity. Now the real magic. So get into the details a little bit. What's required to make this work? There's a number of inputs and aspects, obviously, that are really important. Retail pricing and interval data are fundamental. Rates, energy real-time rates or hourly rates in Alberta are the signal. Optimization of assets to those price signals is the response. Together, they align homes with actual grid needs in near real time automatically. So this is the direction. So we can actually, and with a battery, that kind of response to price signals is automatic and behind the scenes. It doesn't even necessarily affect the consumption or load in the home. But rates, having an hourly rate is not enough to really unlock VPP value. We need metering. You can't optimize what you can't measure. So that's where accurate bidirectional interval meter data comes in. So we'll get into that in a little bit more detail. So with interval metering is the foundation of VPP participation. So I'm pleased to share, if y'all are not aware of an AUC proceeding 27161, in 2022 there was a decision in Alberta which supported small microgenerators. Anybody with solar can request a bidirectional interval meter, which after it's deployed from the distributor, you effectively become a large microgenerator from a settlement perspective. So there's a clear regulatory path right now in Alberta. It's supported by the AUC, a decision since 2022. So we have a number of bidirectional interval meters across the province that are deployed and have been in action since 2023. And I also have an ASO logo there to share that also on their side. Of course, once you become a deemed large microgenerator from a microgen perspective, then you get an asset ID. Your house gets an asset ID from ISO, and then you can participate through an electricity retailer like Solar Utility with a market rate plan. So this provides 15-minute visibility into household energy flows by default, enables customer participation in varying rates. So we've set with our market rate, it's basic, it's a pass-through hourly priced electricity for your imports and your exports. It's a foundation for building more complex and more in-tuned like EV rates, specific rates or time of use, and the energy flows in both directions. So transparent verification of load shifting, battery dispatch, and grid benefits. This is key for a virtual power plant. This is why Blatchford works and why VPPs across Alberta can now scale. And just a note there that it's bidirectional interval meters are now fully supported by EPCOR and AMAX. As Ozair mentioned, EPCOR's got the process right now, so any microgenerator in Edmonton can request a bidirectional interval meter, and there's a process in order to get that deployed. The rest of the province is close behind. Our market rate plan, of course, is the retail engine behind the Blatchford VPP, now available Alberta-wide for all microgenerators. So for the first time, homeowners can get access to true ASO hourly wholesale prices, which effectively allows means that you consume electricity when prices are low, and you can dispatch your solar energy to the grid when prices spike. Same could happen with EVs, and we'll talk about that a bit, all fully automated. As we're all aware, there's volatility in the electricity market, energy market in Alberta, and prices will go from right now sub 50 per megawatt, and they'll spike up to 1,000 per megawatt hour. With the restructured energy market, that's changing. That's moving to 1,500 and then escalating up to 3,000. So being a market participant in a virtual power plant exposes arbitrage and other forms of VPP participation. It's good for the customer. It's great for the distributor because we're providing those resources market aligned. Fantastic for the system operator. So it's really a trifecta, a perfect trifecta in terms of benefits for all parties involved. All right, now the fun part. This is what we're all waiting for. What does this mean for customers? What are the value streams for Alberta microgenerators? So some of these are pretty solid. Some of them are estimates based on assumptions. Look forward to chatting about each one. We'll just run through them because I know we're short on time and want to leave enough time for questions. So First value stream is price optimization. This is available today in EPCOR and max zones. Monthly savings potential of $8 to $45 a month, depending on your assumptions. In this case, for a Blatchford style home, has 12 kilowatt solar, 20 kilowatt ESS, a heat pump with a pretty significant load. So that's the potential, and that's based on volatility just over the last couple of years. It is volatility dependent. But we see with the increase in demand, volatility is very likely to increase, which increases the opportunity for customers to benefit directly from price optimization. So you require a bidirectional interval meter, and you require your retailer, such as Solar Utility, to support hourly settlement for a market rate plan for that to work. Secondly, variable T&D reduction. If you have a smart battery, like a Sonnen, I'm using the Z, I almost caught myself and said Sonnen, but Sonnen. Today, we should call Solar Utility Zolar Utility, maybe. No, today with smart ESS, you can reduce your T&D as transmission and distribution costs just by storing your energy in a battery and self-consuming it. From solar will reduce your variable T&D quite significantly. So we see value of anywhere between $20 and $55 a month, depending on your assumptions. That's not going to make Ozair very happy because we're reducing their wallet share. Actually, that's not the case. we're actually reducing load in peak periods, so everybody's still happy with this, because basically we're going to reduce the T&D when prices are high in an optimized scenario, which reduces pressure on the grid in peak periods. So it's still a win. It's still a win. Third, grid services demand response. This one's coming. This is one we're all talking about and working very, very hard behind the scenes. And we believe with the restructured energy market in 2027, the market will allow aggregation of DERs. So we're working very hard in the background. This is the greatest potential from a revenue perspective, from a per home. We've benchmarked this $50 to $100 per month savings potential based on ERCOT and a few other VPP programs. And basically you're getting paid you'll be paid to stabilize Alberta's grid, which is fantastic. This is the direction. And I did mention a bunch of those grid services. So this grid services, you're also in other markets able to stack those services to increase value. And we see the Alberta market moving definitely in the right direction. But straight up, is probably this bit's not going to happen until 2027. Managed EV charging. This is available today. If you have a smart EV charger in EPCOR and NMAX zones, we can time the pricing. So in this example, just on the energy rate, because you, in theory, not assuming any T&D reduction and reducing your energy cost of EV charging from 8 cents to 4 cents, it actually could go lower than that if you really wanted to hit zero. There's a lot of hourly price periods that hit zero. But you could save $12 to $20 a month on managing your EV charging if you're okay with timing and allowing a little bit of flexibility on when you can charge. You can actually save a lot compared to just plugging it in. V2G export, pretty exciting. We're doing a pilot in 2026. A much larger battery, of course, up to 100 or even more kilowatt hours in your EV. If you allow some flexibility there when prices are really high, you'll be able to dispatch that power to the grid for additional savings. So we hope to prove that model and have some data to share with the industry, likely by Q3, Q4 in 2026. Okay. So that about covers the value streams. There's more. There's more potential here with other DERs. I haven't covered smart thermostats and a few other DER types. This is generally what we think it looks like. So fantastic opportunity. for microgenerators in Alberta, and a shift in the value proposition from not only the benefits of deploying solar, but additional and enhanced benefits for the microgenerators and homeowners once they participate in a virtual power plant. So the Blatchford VPP has been a fantastic opportunity to work with industry partners to demonstrate the capabilities and the potential of virtual power plants. So these 8 homes that we have live currently, they're shifting loads, they're reducing peaks, they're improving the power quality in local feeders and saving the homeowners money. What we've proven and what we're proving in this neighborhood, as an industry, we can scale to hundreds of communities across the province, but only with a partnership. The partnership really matters. So as an industry, we have to do this together. And that should sum it up. I think, again, last point is we have to work together, utilities, developers, retailers, not just solar utility, and other communities. Solar installers are a key, important part of this mix. Together, we can build a resilient Alberta grid and save everybody lots of money. Everybody wins. Thank you so much. I think that's wrap up my presentation. We can now get on to any questions that the group has.
Thank you so much, Kelly. I appreciate your presentation. And Dulzair and Stuart, if you want to join us on screen now. Kelly, I think you can just take your screen share off and we will just have the 4 of us up on screen for the Q&A. Perfect. So we have lots of questions coming in, 19 already. You folks are very popular. I was hitting a couple of you up in the chat on the off chance you might be able to go a few minutes over. We might, I think folks would appreciate that. Is that something that any of you have time for? I don't want to put you on the spot here, but you could handle a couple minutes over? Okay.
Yeah, no worries.
Okay, thank you so much. Then we'll hang in here maybe till let's say 11:10 Mountain Time, so that we can get through a lot of these questions. You're so popular; we had well over 100 people attending today, so I'm not surprised that there are now 20 questions and counting. Just a reminder: we're not going to get through all the questions today, so please make sure you're upvoting questions that you want to hear responses to, because we're definitely not going to get to the ones at the bottom. All right, Ian has a question here, which I think you started touching on there, Kelly, but I think folks would love for you to expand on. How is the customer compensated for its investment in storage and the value it provides to the utility? Storage struggles, certainly at commercial rates in Fortis area, for economic justification without the additional cost of batteries. Even with time of use rates, this will not generate the return on investment within its life cycle. I know in this situation, I believe Emissions Reduction Alberta came in to subsidize the cost of the batteries for the homeowners. But is there any way for this to work without that type of ERA support in Alberta?
Maybe I'll go first. Absolutely. Battery prices, solar system prices obviously reducing pretty significantly over the last few years, making the ROI much more palatable. Straight up, we have to get more than just price arbitrage happening to pay for the value of the battery. The advanced grid services, participation in demand response programs is key, but we can see in other markets fantastic references of that, where demand response and grid services programs more than cover the cost, the capital cost of the battery, will provide a less than 10-year payback period on the battery, in addition to also providing home resilience with backup power for the grid. So there's definitely a path where this is viable and feasible, and it's proven in lots of other markets. Maybe I'll pass to Stuart.
Yeah, great.
No, yeah, I would 100% agree with that one. Certainly you have tax incentives and those things on the government, but we're seeing more and more, and I think this will change over time, that this can be sustainably driven without that. If we use in terms of, I'll use one, it's not to say this happens in every utility market, but the WattSmart program is based on Rocky Mountain Power. It's the state of Utah, not the state running it, but within the state. It's been going for 5 years. There are 5 different battery manufacturers that have met the performance requirements for Rocky Mountain Power. Rocky Mountain Power receives 9 grid services. One of the grid services alone allows them to pay for the incentive of somebody putting in a battery or solar and battery when they first started, or adding a battery to a current solar, and pays for the annual incentive each year for when they're using it. Mm-hmm. So they're reaping great cost savings or things on their own. We can't go behind their scenes and see all that they do, but they're in the program. They advanced the program. They've been doing it for 5 years. So if someone's looking to think that the ROI is 2 to 3 years, yeah, that's difficult. But it's the difference when you flip it between recognizing that this is much more than just an asset that waits for the grid to be in trouble. This is more one that manages your own energy usage, gets you a better rate savings every month, as well as drives you incentives down the road, as well as on an annual basis. Then it has become a win-win-win across the board for both grid, utility, and the battery owners.
That's a good point, Stuart. I think most of us are used to just thinking about batteries in terms of kind of supporting an off-grid scenario where it's just providing electricity when the sun's not shining. But this is a very different type of battery setup that would have a very different ROI than than the traditional battery setup in Alberta. So thank you for that context. Anything to add there, Ozair, before I jump into the next question?
No, I think Stuart and Kelly covered it really well. It's really the stacked sort of premise of the incentives plus the participation in like the wholesale market or the whatever energy retail plan that's potentially getting you some benefit there, and then also the benefits that you would get from the utility, from being part of a utility run program, to whether to incentivize or participate or like just be available to participate. That kind of thing is, I think that stacked benefit is the only way to make it work. There isn't a framework right now to do that on the utility side, but we're hoping that with this project we can show that there is a benefit of either a capital cost deferred or a capital cost avoided to the AUC, and therefore like build some regulatory frameworks around that, or at least help the AUC see that there is value there.
Yeah, so they might want to build in more incentives too to make it happen if it benefits the broader system. I'm going to say the one thing you guys haven't said on that is I certainly wouldn't object to a little rebate like BC has for batteries just to kickstart us in this direction, because it would really give us the boost to get the price of batteries down here if we had a little government support to get us started. But I know you're all free market folks, so I won't talk about that too much. But and I know our audience is too. They hate it when I talk rebates, but it's a nice kickstart, and it helps lower income folks participate who might not otherwise be able to. So that's my personal dream there. But appreciate that there are benefits that are not necessarily requiring that type of government involvement. Alejandro says here, hi Ozair, I'm not totally clear on who actually owns the system. Is it the homeowner? How does liability work, for example? If a battery needs replacing, who pays for it? Thanks for that.
Yes, so the system is owned by the homeowner, and they're responsible for it. And if they choose to participate in sort of a VPP program, whether it's the retailer or in the future with directly with the utility participating, then they would be. This is my interpretation. Kelly, you can jump in and correct me if I'm wrong. But yeah, the homeowner owns the asset, and they're responsible for the asset and its upkeep. So like if you want to participate and your internet connection's down and you miss an opportunity, that's you need to maintain your internet connection. You need to maintain the battery, all that stuff. Yeah.
Okay. Good to know.
If I can, only thing I'll add about batteries being the vendor, we support the contractors who install the batteries. The batteries come with 10-year, 10,000 cycle warranties. And that's going to be, most batteries you'll see will start do that, but it's all going to come down to which battery you choose or what you can do. But I'll speak us on it. 10-year, 10,000 cycles if a battery fails, and our warranty is across the board, all encompassing. So it's if you're using it and that type of thing. So the battery will be more likely, like if it's a battery homeowner that owns it, they're going to have support from their contractor or contacting Sonnet.
Many of whom are members of ours, actually. So those battery and solar installers, people will often find them in our directory. And if they, for some reason, go out of business, we've got other members who do maintenance on old systems too. So we've got you covered, folks, if you've got a breakdown and if you want to buy in here. All right, Alejandro again. Also, where are we at with two-way charging for EVs? Oh, thank you. I wanted to ask this because I have an EV and I was like, maybe I could get away without getting a battery. It'd be so much cheaper. Using EV batteries makes sense from a technological perspective. They are already plugged in, and investment perspective, dual use. But I've heard that the main challenges are regulation and cooperation from EV manufacturers. Is that the case? Thanks. Who wants to take this one first? I know you all touched lightly on EVs, but maybe does anyone want to dive into that a little bit more?
Yeah, I probably can, unless Jose, you want to take the...
I'll let you go first.
Okay. Happy to. Yeah, regulation, basically from our perspective, there isn't a regulation that says you can't use your vehicle. With the solar system, if the solar is charging your EV and then you're using that for vehicle to grid to dispatch that solar generated power during high period peaks, it's, from our perspective, it's just as it's another battery that's behind. There are challenges for sure, especially bus bar, adding another source breaker to a 100 amp service is really difficult. You have to implement a really complex energy management system in order to meet the permitting requirements. So that's a challenge. But we are introducing a DC coupled EV charger that should help that challenge. So it's not without challenges. That's why next year we're doing a pilot, but in alignment with the comments, it does have fantastic potential, and having a battery that large that's accessible and can participate in virtual power plants, should deliver incredible savings potential for homeowners when it does roll out at scale.
Yeah, thanks. I mean, I know electric vehicles are costly right now, but we're hoping the price point on that will drop if the Saskatchewan and Manitoba premiers have anything to say about that. I think they've been trying to get more Chinese EVs permitted and things like that. So we might see that shift a lot, and maybe that'll enable folks to consider this more readily. Was there anything to add there?
No, I think from the utility perspective, anything that outputs onto the grid, we have to know about, but we don't necessarily need to control it, right? It just we need to know like how much it's going to be outputting, what the maximum output is. So typically, anybody who's going to be exported to the grid would need to be like a microgen, like a small microgen or otherwise. And so there's an application process. It would be the same application process. But we don't really care what the behind the meter resource is. Necessarily, as long as we know that there is a behind the meter resource there. As we do more of these like virtual power plant type implementations, then we would like to know what is there, especially if they're going to be participating in some kind of program. Just because, like I said, one customer doing something doesn't really make that much of a difference at any level of the system. But a group of customers that are banding together to do something, well, that's a different story, right? Especially if that band of customers gets bigger and bigger.
Yeah, that's a very good point. And so right now you're battery agnostic, and if your battery happens to be an EV, no big deal. But down the road, you're going to need to know what people are using there. Hey.
Yeah, and I think one of the key aspects is that if you're going to be outputting from your EV, first make sure that you're not voiding your warranty. That's really important. But then second, I would say the AC side of that, right? Like the maximum AC output from the battery, that's something that we would have to record in our systems, right? But that would be part of the microjet application.
Yes, yes. My biggest disincentive to do that is I always think, well, when the zombie apocalypse comes, I'm going to need my EV to be fully charged to get out of Dodge, right? So so I don't know if I'll ever jump on that bandwagon, but I know a lot of people are less scared about that apocalypse, so they might be ready to contribute some energy from their from their car. All right, here we go. You stated that a VPP integrated with a utility like EPCOR can potentially provide additional revenue to a customer. Does that not run counter to the intention of the Alberta microgen regulation? I just want to start on this, Ozair, and then I'm going to pass it to you. I think there's a lot of misunderstandings in Alberta because as I've learned more about the microgen regulations across the country, I've discovered we're really different. There's a reason why there are 40,000 homes and businesses with solar in Alberta and why you're not seeing that uptake in other provinces. And that's because our microgeneration regulation doesn't actually say thou cannot make any money. It doesn't comment on money at all. Our microgen regulation is very different than the others. It just says, you cannot produce more than you consume in a given year. And the money piece is a sort of separate thing that you deal with. And so I think that context is really important for anyone joining us out of province. They do have, those financial pieces in their regulations that are very different than ours here. But yeah, Ozair, I want to take it away on that piece and how it is that microgenerators here can have a bit of additional revenue in general.
Yeah, so the additional revenue that I was referring to is specifically that utility piece, right? I think if you look at Solar Utilities' rate plan that they're sort of offering, that they're proposing for this virtual power plant implementation, it's using the wholesale market, right? And so you could be importing energy at $0, and you could be selling energy at like $1 per kilowatt hour or something like that. And so obviously, if you do that really efficiently, which their energy optimizer is really designed to do, then you will make money, right? And without necessarily impacting your consumption in any sort of like really appreciable way. But the specific thing that I'm referring to is the utilities, I guess the future, hopefully, utility program and regulatory framework that allows utilities to pay for the services of a virtual power plant, because that service is by default offsetting the need for a more costly physical infrastructure upgrade, right? And so we're looking at sort of non-wires alternatives as opposed to the traditional wire solution. In a traditional system, like up to today even, right? Like because we're still proving this out. If I have a capacity issue, whether it's a generation issue, like being able to host generation or being able to host load, I have to upgrade a cable or I have to install additional cable, right? That's like hundreds of thousands to like millions of dollars to do. If I can quantify the benefit that I get from customers banding together and offering me 500 kilowatts or like 5 megawatts of generation capacity or demand reduction, right? That means that I potentially don't need to do that upgrade, right? Which is millions of dollars that doesn't go into the rate base that then everybody sort of has to pay for on their fixed fees, right? So that's kind of the trade-off that we're trying to quantify. Is okay if I don't have to install this wire in the ground, right? And this customer has taken they have decided that they're going to install a battery. Can I pay this customer less than the millions of dollars that I would have had to pay, right, to let me use their asset so that everybody doesn't have to pay?
That's
right?
so Albertan of you, like contracting out your. How can we contract this out? I love it.
Yeah. Well, it's designed to be to the net benefit of all customers, right? And it's totally voluntary. It's not like we would be forcing this on anyone. If someone didn't want to participate in the program, right, they would forego that incentive to have full control of their battery. But if they did want to participate and they were willing to, be a part of that and also get paid for it, then we would be open to having that conversation, given that the appropriate regulatory framework existed, which it doesn't right now. But we're hoping to showcase that it can with this project.
Very cool. Thanks, Ozair, for explaining that. So you were talking a little bit differently than the financial side of things that Kelly talks about. Kelly, do you want to add anything there in terms of the financial piece?
Yeah, just that I think grid services, if we just call all of these opportunities grid services, they're stackable So we can, with the Blatchford home in particular, Solar Utility will run a price optimizer to make sure that the homeowner gets the maximum possible benefit of buy low, sell high on the electricity price. That is stackable with EPCOR's integration and control from an emergency demand response perspective. So they can actually operate at the same time, and value stacks up as you participate in more services. They're not going to shut each other off.
Yeah, I appreciate that. Okay, question here about scale up, which of course, because everyone's just sitting here being like, me too. I happen to live across the street from the virtual power plants, and so I always think about that. But so the question here is, can we get a brief overview of the next steps to expanding the VPP to the larger EPCOR and Edmonton service area? I know you had ambition there in your presentation about going bigger. Do you mean bigger just as a pilot, or how can we break free of perpetually piloting? Ozera, do you want to start with that? the perpetual piloting issue.
Yeah, the perpetual piloting issue is a real problem, even at EPCOR. So I feel that pain on a regular basis. So I guess I'll start off by saying that a big part of this project is a demonstration of the capability to do this, right? And so we have spent the last 2 years developing that capability, developing the techniques, figuring out like our own business processes, and what changes to those business processes are required to scale this up. And so we're trying to basically get to a point that by the end of this project, we will be ready to adopt any VPP that comes into the system. Anybody who wants to join will have automated processes for all of that, right? And they'll be well understood within the business, and we'll be able to indirectly intake these customers. Right now, it's a very manual process because it's very new, and we've only done, like I said, like eight units so far. We're planning to get to, like I said, 26 by the end of the year, and it requires like special training for each of the individuals that are involved in that whole process. So we're not there yet in terms of being able to like scale up, but in the next year, we're going to automate most of that business process, and most of the actual intake piece. Like, we figured out how we want to do it, we've figured out the architecture, and we're just developing that documentation, and then also continuing our testing with the existing homeowners and the existing assets in the system. So my answer, I guess, to like long story short, is that we're not ready to scale right now, like today. But this time next year, we will be much closer. And this time 2 years from now, I think we should be pretty much ready to go.
Yeah, and we're going to be hauling you guys back in here in a couple of years' time for sure. Stuart, how about you? I'm sure you've seen these scales, Stuart, around the world. Want to comment on that at all?
I mean, certainly. I think I'm going to speak in a different way. In terms of working on an aspect of the VPP, that'll be driven really, like as Ozir just mentioned, as they grow, what they want to do and move forward. And that's fantastic, because they need to manage what they have to manage and go with it. On the backside, what would help him or help any utility or any community better is, how do you get more batteries on the ground? Because the solar alone is not going to do it. With that, I was going to turn. I didn't know if Kelly wanted to say anything on it, but typically it's that, is you can move forward with, if you're going to add solar, more than likely, in my opinion, you need to add a battery. Now, you can look at them. I won't just push Sonnen, but our platform and what we're doing here can manage multiple. But when you look at a battery, you want to make sure that what it can do. But that's your first step, because that's the asset on the ground that's letting it balance. So really, the attitude is, how do you move forward on that one? And I think Solar Utility's looking at some really smart things that they're doing and can offer. But Kelly, I don't know if you are ready to talk about any of that here, but to me, that's just how do you move forward and scale, get more assets on the ground, and then with it, the utility will then be able to fold those in to their virtual power plant program as they see fit and what they'd be able to do. So,
yeah, maybe I'll just add to that. I think in other markets, aggregators and retailers provide sort of some highly customized and unique solutions. So in Texas, batteries, there's a larger demand for home backup there. but it's now commercially driven off of savings. So you have companies like Solright, Stuart, if I might speak on behalf of Solright, doing mad, crazy deployments, just unbelievable scale for Sonnen in Texas, rolling out zero down batteries. So if we structure it with financing, it makes it easier for consumers, and they still get to see a fantastic savings from the package where batteries are deployed basically zero down, and it becomes part of the retailer's offering to the end customer. So we need to develop programs like that and a PPA to provide better access to batteries, and that's what really is creating scale in other markets. I call it creative retailer programs and plans that include batteries for end customers. So that's what we need to do in Alberta.
Well, I'll tell you, our installers are getting ready to gear up on that asset front, because our popular courses are always the codes course and the batteries course. And of course, why is code so popular right now? Because the battery codes are better now. I mean, I understand you can put them in homes now where that wasn't even possible a couple years ago. So there's certainly some change afoot, and I always get a sense for that when I see the diversification of our installers and how they're preparing for the next steps. Stuart, did you want to add something there?
Just want to add, because what Kelly said, so down in Texas, the partner we have, there's things called PPAs, power purchase agreements, so that you're working that way. You're buying in, and what you're doing is they put assets. What Solright and Sonnen created was a virtual power plant power purchase agreement, and some made it a VPA. And that's what they're doing, is, as what Kelly mentioned, that they've created a fantastic financial model that comes into play, that you have a utility rate, but it's zero money down. I'm sure there's questions, people wondering, how do you reduce the cost? Those are programs that can come, but a lot of times it may be a financial organization that's recognizing how they can do this and drive their money. And that's what there are a lot of different programs. I think it's going to, hopefully something will come or develop out of Alberta. There's probably smart people out there looking at this already.
Yeah, well, Canada does have Business Renewable Centre Canada. We did have them on a couple of years ago to do a power purchase agreement webinar, so people can find them on our YouTube channel if they're curious what these PPAs are. Of course, they're usually talking sort of those traditional solar farms that you mentioned, Kelly, whereas you're talking about a very innovative, micro generator solar farm. That I know you and some of our other, retail members are operating already. So interesting to think about how that looks with a power purchase agreement. So we'll have to bring you back on that virtual power purchase agreement topic at a later date. We do still have 70 keeners on the line who are diehards who want to go the extra mile with us here. So thank you for committing to stay with us till 11:10. This question is like multi-layered, and you may want to open up the Q&A for it because there are kind of many questions embedded in it. So this person says, if I understand this right, EPCOR is spreading out its infrastructure upgrade responsibilities paid for by the consumer. So that's sort of that contracting out bit that we were joking about earlier, I think was there. And then so that they can inject power into an ES and then slurp it out when they need it. I like this slurping.
That's exactly how it works.
I hope you're slurping with, a paper straw there, was there? That's the big paper straw controversy. This seems to defeat the purpose of solar generation / storage for the homeowner to use during non-solar hours. So that's an interesting point there. But then the question goes on. And at what price point? Spot market, question mark. It would seem the AUC would have an issue with a system that could require a payment to the customer up to the market cap. The regulations are pretty clear that the customer gets paid what they pay, and I have read that. That is pretty clear. So undefined upside charges is a risk to all Albertans, as guess who has to cover the spread. So I don't know who wants to take a stab at that question. Maybe Kelly, do you want to start on that? I know you probably know that microgen reg inside and out, and you love to talk to the AUC. So I'll let you take a stab at that very broad question, which covers a lot of points. Kelly froze after saying sure. Okay, Jose, it's coming to you first then. And maybe Kelly will unfreeze by the time you get through your answer.
Sure. Yeah. Okay. So yeah, I just want to clarify. Like, EPCOR is not trying to spread out the infrastructure upgrade responsibilities. It's the infrastructure upgrades that happen are sort of that's all part of the regulation, right? So we file for all of our expected capital projects, and then they get approved by the AUC, and then that goes into the rate base, right? So those fixed fees that you pay on your bill are to pay for the regular upgrades and maintenance of the system and growth of the system, right? That's everybody's paying for that. The challenge with that structure is that it's quite expensive to do upgrades like that, especially in mature areas where especially in Edmonton, where we're expecting to see like infill, we're expecting to see like EV adoption. We're seeing a lot of sort of growth in AC load, and then potentially in the future heat pump load as well. So the question becomes, is that the most financially viable strategy to just install a bigger wire in the ground, just to install another wire in the ground to support that? And if we went down that road, EPCOR would continue to install those assets, and we would make a return on those assets, and it would go into the rate base, and customers would pay for them on their fixed fees, right? What we're trying to do here with this project is we're trying to evaluate a non-wire solution that is potentially less costly to the end customer, right? So it's not us trying to get out of our responsibilities. It's us trying to do something that is hopefully beneficial to all customers in our service territory.
Yeah,
because what will actually happen...
I was thinking, like, if you guys weren't a municipally controlled corporation, you'd probably have very little incentive to explore non-wires alternatives. So it's quite nice of a wires company to consider non-wires alternatives, and really, you know, because you're a municipally controlled corporation, you know, you're actually a public servant first and foremost, and so that's a neat sort of turn of events here in Edmonton.
Yeah, absolutely. So because the customer owns that asset, we don't make a return on that asset, right? And because we didn't install additional wires or bigger wires or whatever, we don't make a return either. So in a way, I'm sort of like undercutting myself to support like this. But I think in the grand scheme of things, this is net benefit to both the grid and to customers, and so that's why we're supporting these types of projects. Then sort of I think the second point there is EPCOR has zero plans to inject power into any energy storage, right? The energy storage for this project and for the foreseeable future, as far as we're concerned, if you're going to install solar plus battery, your battery should be charging on the solar so that it can then be utilized later in the day when the sun is not available, right? It just happens to be that typically when the sun goes down, all of the solar in the province also stops producing, and so that's when typically the power price in the wholesale market will go up, right? That's typically but that's also around the time that people need power, right? They're getting home, they're cooking dinner, they're drying their clothes, they're charging their EVs, for example, and that's also when so like the free generation that we had all through the day is gone, so now you have to activate that spinning generation, you know, like that's more traditional, right? Or you might have to fire up one of the peaker plants to accommodate that increase in demand at that time when the solar is not available. And it just so happens that if you discharge your battery during that time, not only do you lower your demand, like as an individual customer, but if 1,000 customers or 10,000 customers all lower their demand at that same time, now potentially you don't need to load up on the generation side because you're handling your load, right? Mm-hmm. And if you do that because the utility asked you to do it at that time, right, and the utility paid for that through some future regulatory framework, then that's great. And you potentially benefit on the retail side as well, right? Nice. So that's kind of the dual incentive. Well, it's only one incentive right now, but in the future, potentially dual incentive to participate in a program like that, right? So the way that we're looking at it is like very holistically, a lot of these things line up because solar is going to decrease, right? And if you decrease demand at the same time, then that load profile stays relatively flat, which means that the AESO has a better time planning for generation to come online, which means that they're not paying even more for that peaker generation, and customers are benefiting because that's when they would have used their battery anyway during that period when solar wasn't producing as much, right? And then it benefited the utility as well, and maybe the utility also paid for that as well.
Yeah, so you're not sucking those batteries dry and leaving folks with nothing there for them
No,
to
no,
use
no.
at night. They're the ones using the batteries for the most part to lower your peak. I really appreciate you explaining that. Kelly, welcome back. You froze and we put Ozair on the spot. But I said maybe he'll be back by the time you finish your answer, and here you are. Thank you for rejoining us. We're going to have you follow up on that question, and then we're going to close out because we are 10 minutes over now. So anything to add there on that last very complex question, and I appreciate the complexity of it because this is a complex topic.
Yeah, I mean, first, I think on the microgeneration regulation, you hit the nail on the head. It does support, it's unique, and it does support this in Alberta. ASO actually welcomes and has an open door for large microgenerators. So we're deemed large microgenerators in this situation. If we're injecting power when prices are high, we're reducing that requirement. We're helping the grid. So it's a net benefit for the grid when we're doing price arbitrage, and we capture that economic upside by optimizing, when we ship our power to the grid. So I think that maybe answer one question. So microgeneration fully supports that. There's some smart folks early days that designed that regulation and saw the future and allowed a way for microgenerators to move forward into a more advanced integrated market that has hourly settlement and tracking of your generation. So frameworks there, it's fully supported by ASO in terms of settlement and our retail offer, and also again AUC from a regulatory perspective confirmed that in a proceeding in 2022. So we are really good to go.
Yeah, awesome. Well, thank you so much, Kelly. And thank you, Stuart and Ozair. And I sure appreciate the three of you going over time here with us because we did have such an enthusiastic audience, and 65 of them still with us going strong so far into this. So thank you to our incredible audience today. I love it when our audience is excellently nerdy, and so that was super fun today. I also want to make sure I thank EPCOR again for being our workshop patron, and Lakeland College for being our sponsor for this event. We really couldn't do these sorts of things without them as a small nonprofit. Seen lots of thanks in the chats to you all. So I'm gonna hopefully see you all in the new year at the Solar Show last week of January. A big shout out to our staff for pulling this together today as well. So have a wonderful week and enjoy the sunshine today. I hope it's shining where you are. I know it certainly is here, shining on the VPPs in Blatchford where I live. So thank you all. Have a wonderful day and look forward to learning more from you again in the future.
Thanks, everybody.
Thank you. Thanks all.